Hi students, today we are going to discuss on how to solve the quadratic inequalities by three different methods. The first method is the graphing method, second method will be the number line method, and the third method will be the table method. Let's look at the example. Solve the quadratic inequalities s plus 1, s minus 3 greater than 0. Solution. Okay, so look at the quadratic inequalities. We can find that the roots for the quadratic is the negative 1 and 3, right? So the roots x equals to negative 1 or x equals to 3. By using the graphing method, we sketch the graph. And this is positive quadratic inequalities, means that this will be a minimum graph. Okay, now we draw a minimum graph. Okay, this is a minimum graph. Draw a minimum graph, x-axis. And I just simply draw a U shape to show that this is a minimum graph. Label the root negative 1 and 3. Greater than 0 means that we are going to identify the positive area. The positive area is the area which is above the x-axis. Above the x-axis and in between the curve and also the x-axis. Okay, in between the curve and also the x-axis. So this is the positive area. Okay, this is the positive area. Then we want to solve for it. X plus 1, x minus 3 greater than 0. Then the positive area is going to show x is greater than 3 or s is less than negative 1. If I want to find the quadratic inequalities, which is s plus 1, s minus 3 less than 0, means we are going to get the negative area. The negative area which is located at between the graph, and also the x-axis and below the x-axis. Okay, below the x-axis, the graph and also the x-axis below the x-axis, which show that this one will be the negative area. Okay, this is a negative area. To solve this one, we are going to have x will be in between. This area is between negative 1 and 3. So these are the two different situations for solving the quadratic inequalities by using the graphing method. Then we continue to solve the quadratic inequalities by using the number line method. Still using the same question, same example, and the roots are negative 1 and 3. Draw the number line. This is number line. And we label the point negative 1 and also 3. And the quadratic inequalities is greater than 0. Greater than 0, we draw a dot here and always point to the positive side. Always point to the right or the positive side. So we can determine the part which is passing through the line is the positive. Label it with positive, positive, and finally this is a positive part. And there is a line passing through, positive, negative, and this will be the negative part. And finally, the last part, which is we don't have any line passing through it, so this will be the negative, negative, finally negative, negative become positive. And the question wants us to show the inequality which is greater than 0, means we are going to get the final answer with the positive area, which is this part and also this part. The final answer we can write as x is greater than 3 or s is less than negative 1. This is the number line method. Now we're still using the same example. We are going to the table method. Just simply draw a table like this and label the table with, the first one will be x plus 1, then x minus 3, and finally we have s plus 1, x minus 3. Okay, and for the refer to the number line just now, okay, number line, where we have the area negative 1 and 3. There are three parts, right? So this part is the x greater than negative 1. This part is between negative 1 and 3, and this part will become x greater than 3. So we label like this, x less than negative 1. Okay, the middle one will be x in between, okay, in between x and negative 1 to 3, and the third part will become is x greater than 3. Okay, assume that we check when x plus 1, x less than negative 1, we just simply take any checkpoint which is fulfill the condition of x greater than negative 1. Example, I take for x equals to negative 2. Substitute x equals to negative 2 into the equation here, negative 2 plus 1, and then I'm going to have the answer negative 1. This is not fulfill the condition greater than 1, so this is negative, right? So when x equals to negative 2, I substitute to the x minus 3. Negative 2 minus 3. The answer come out is still negative 5. So this is a negative, okay? Negative. And finally, negative multiply with negative, I'm going to have the answer for the positive. For this example, okay, for the second part, I take the example from the negative 1 to 3. Just take any point which is fulfill negative 1 to 3. Example, I take for 0, okay? X equals to 0. I take the value x equals to 0. Substitute. 0 plus 1 is 1. So it's a positive, right? 0 minus 3, okay? 0 minus 3 is negative 3. So it's the negative. And finally, positive minus multiply with the negative. I'm going to have the negative. And the last one, I'm still using the same method. x greater than 3, I just take any value which is fulfill x greater than 3. Example, I take for x equals to 4. Substitute, okay? Substitute to the equation. 4 plus 1, the answer is 5. Positive, okay? And now, I still have 4, okay? 4 minus 3 is equal to 1, right? Still positive. Positive and positive, finally positive. And finally, we are going to look at the inequality. The inequality wants us to get the part which is greater than 0. Greater than 0 means that I will take all the positive part, okay? Greater than 0, I'm going to take all the positive part that is here and here, okay? This is the answer that I want to take here and here. And the answer final come out will be x is less than negative 1, s is greater than 3. So this is by using the table method. Okay, now we go for another example which is involve the maximum quadratic inequalities, where we can see that 1 plus x multiplied with 2 minus x greater than 0. By using the tree method, first we have to identify the roots. I can find that the roots from here is x equals to negative 1 and x equals to 2. Okay, now we look at the first method. By using the graphing method, then we can see that this is the maximum quadratic inequalities, means that this will be a maximum graph. Okay, maximum graph is an N-shaped graph. Just draw the graph. I just draw an N-shaped graph, which is showing me the maximum graph, and label the roots, negative 1 and 2. Greater than 0 means that I want to take the area, okay, above the x-axis, positive area, above the x-axis and in between the curve. Above the x-axis and in between the curve. This is the positive area. And the final answer will become x in between negative 1 to 2. If I change the equation, okay, I change the equation become 1 plus x, 2 minus x less than 0. What happened? Okay, 1 plus x, 2 minus x less than 0 means that I want to get the negative area. Where is the negative area? It's in between the x-axis and between the x-axis, below the x-axis and the curve. Okay, below the x-axis and between the curve. This will be the negative area. This is the negative area. And the final answer come out will become x is greater than 2 and x is less than negative 1. So just a little bit different in between the maximum and also the minimum quadratic inequalities. Now the same question again, I repeat with the number line method. Okay, number line method, this one have to be very careful. Second, number line method. Still drawing the number line, label with negative 1 and 2. S plus 1 plus x. 1 plus x means that s plus 1 is equal to s plus 1. So we know that the root is negative 1. Greater than 0, they will become always going to the right. Okay, going to the right. But when it comes to 2 minus x, okay, 2 minus x, the root is 2, right? So because this is 2 minus x, then the arrow will be going to the left. Going to the left. Starting from here to going to the left. And where the arrow passing through, the line passing through, we are going to label it with positive. This is positive, negative, and finally negative. This part, there are two lines passing through, positive, positive, and also finally positive. This part, there's no line, means this is negative, this is positive, and finally this is a negative. And we want to take the part which is greater than 0, means the positive area. So this is the answer, positive area. X in between 2 and negative 1 and 2. Okay, now we go for the last part, is the table method. Table method. Question number third. The table method. Draw the table again. Okay, draw the table. Label it with 1 plus x, 2 minus x. 1 plus x, 2 minus x. And this will be the 1 plus x and 2 minus x. And the part where is x less than negative 1, x in between negative 1 to 2, and finally we have x greater than 2. Okay, we choose a value of x which is fulfill x equals to negative 1. Example, I just take x equals to negative 2. X equals to negative 2. Substitute here, 1 minus plus negative 2, the answer is negative 1. Negative. Okay, 2 plus 2 minus negative 2, so I have 4 positive. Negative, positive, finally negative. From negative 1 to 2, I just choose for 0. Example, I choose for 0. Substitute 0 into the equation here. Substitute, let's say I put 0 here. 1 plus 0, 1, so it's positive. Okay, so 2 minus 0, 2, still positive, and finally this is positive, right? And the last part, x greater than 2. I just choose the value for 3 example. Okay, 3, substitute here. Okay, substitute 3 into the equation. This is 3, 1 plus 3, 4, positive. Okay, 2 minus 3, negative 1, negative. Positive, negative, finally negative. And the inequality is 1 plus x, 2 minus x, greater than 0. Okay, greater than 0, again, we take the positive part. So this is the part that we want to choose. And the final answer come out is 1, x in between, negative 1 to 2. So this is the final answer.